is Sarah Hutchinson, and I'm an MSMS graduate student. My research has focused on quantifying the plastic ingestion rates of wedge-tailed shearwaters as the Hawaiian archipelago experiences increased amounts of marine debris due to northeast trade winds, the surrounding bathymetry, and the placement inside the North Pacific Gyre. My research hopes to investigate and quantify the amount of marine debris that pelagic species are ingesting within the Hawaiian archipelago. Wedge-tailed shearwaters are a locally breeding seabird found in the main Hawaiian Islands and the northwestern Hawaiian Islands. They're great for microplastic studies because they're found in abundance and there's a readily available sample size. They're also great biological indicators because they aggregate with lots of fish, including tuna, and they're good indicators for marine debris trends around the Hawaiian EEZ and surrounding waters. And as you can see on this map, the majority of the breeding colonies are found on the windward side, which is where we got them from Sea Life Park. So the research aims of this project was to identify if plastic ingestion varied between several variables, including year, natural food, and natural non-food presence, by stomach chamber, because they have two, the proventriculus and the gizzard, and the type of debris consumed and the type of plastic consumed. Our methods were divided into 4 sections, the first being necropsies. In the breeding seasons of 2011 to 2014, injured wedge-tailed shearwater chicks were taken to Sea Life Park for rehabilitation. The ones that did not make it were donated to the Oceanic Institute for future studies. And we had 110 chicks, and 107 of them were viable for necropsies. We then looked at both stomachs, the proventriculus and the gizzard, and divided the contents into 3 categories: plastic, natural food, like prey, crustaceans, fish, and squid, and natural non-food like twigs and rocks. Each of these categories were weighed and counted, and the plastic that we found in the stomachs were sent to CMDR, the Center for Marine Debris Research, for plastic analysis. Here we looked at the colors of each plastic, we weighed each individual piece, and we looked at the polymer type using FTIR. Lastly, we did data analysis to test for significant differences between variables. Our results show that over 60% of wedge-tailed shearwaters ingested plastic between 2011 to 2014. Even though the remaining 2 years of the study they ingested less plastic, there was no significant difference by year. Each bird averaged 2 plastic fragments and 127 squid beaks, so there was a significant difference between natural food and plastic, and natural food and natural non-food. However, there is no significant difference between plastic and natural non-food, considering that they were ingested in such small quantities. Previous studies have hypothesized that birds that eat more plastic eat less prey. However, in our study, there is no correlation between squid beak presence and squid beak mass and plastic presence and plastic mass. In regards to plastic by stomach chamber, wedge-tailed shearwaters have a 2-part stomach, the first being the proventriculus, which leads down to the gizzard. In our study, we found 111.5% higher plastic presence in the gizzard compared to the proventriculus. And as you can see, the average plastic mass in the gizzard was also more than in the proventriculus. And in regards to statistics, plastic presence, mass, and the number of fragments were all significantly more in the gizzard compared to the proventriculus. So this shows the value of examining the gizzard. In many ingestion studies, scientists take barf samples, which only quantifies the amount of plastic ingested and present in the proventriculus. However, because we completed necropsies, we were able to look at both stomachs, and this shows us the value in also examining the gizzard. In regards to polymer type, over 81% of the ingested plastic was polyethylene, followed by 16% polypropylene, and a small percentage of a polyethylene and polypropylene mixture. These were the 3 polymers found in our seabird stomachs. There is no significant difference by year, so the presence and mass of polymers did not change over time. However, there was a significant difference by type. So polyethylene was found significantly more than polypropylene and the mixture. This could account for the majority of microplastics in the North Pacific being made of polyethylene, so the seabirds might be ingesting more polyethylene due to its sheer abundance in the area. And some sources of polyethylene include plastic bags, various types of bottles, toys, and packaging film. We divided our plastics into 3 different color categories: white, low visibility, and high visibility. Low visibility plastics are darker colors that are hard to see on the surface and in the water column, while high visibility colors are brighter and they're more easily identifiable in the water. And then so we found that the majority of plastic ingestion was white, followed by low visibility plastics, and then the least amount ingested were high visibility plastics. There was a significant difference between high and low visibility and white and high visibility. The majority of the microplastics in the North Pacific are white fragments, and so the wedge-tailed shearwaters could be eating white plastics for the most part just because of its high abundance, or they could be eating the white plastic because it mimics the colors of prey like small fish and squid. In conclusion, this study provides further evidence of parents feeding plastic to their chicks, considering that they were too young to forage by themselves yet. Stomach contents were predominantly filled with prey, and it was significantly more than the plastic that they consumed, and that did not change significantly by year despite the various oceanographic variables at play. Most plastic was found in the gizzard, so this shows us the importance of examining both stomachs. And white polyethylene fragments were ingested the most, which might reflect the majority of plastic types in the North Pacific, or the type of prey that they thought that they were consuming. And no sheet or foam were found, so this shows favoritism towards fragments and small lines. An additional study should look at how this plastic affects the health of these chicks and whether plastic is coming from the water column or in the prey themselves. And here are my references, and mahalo.